All right, hello, this is section 3-5, scatter plots and trend lines. Today we're going to be able to create and interpret, which means talk about scatter plots, and we're going to be able to use trend lines to make predictions. Okay, so first of all, we need vocabulary. So a scatter plot is a graph with points plotted to show a possible relationship between two sets of data. Okay, so you're going to notice in a scatter plot, it's just points that are scattered about. Okay, there's no line on it or anything like that. That's all it is a bunch of scattered points, and that's why we call it a scatter plot. So for example, here we have at a junior tournament, a group of young athletes throw a discus. The age and distance thrown are recorded for each athlete. So here we have the ages of each athlete and distance thrown. So this is athlete A. I don't know, maybe that's Andrea, is 12 years old and she throws for 20 meters. So you can see here age versus distance. 12 years old, 20 meters. Right here is the point for Andrea's throw. Okay, B might be Brennan. Okay, Brennan is 16 years old and throws for 35 meters. So 16, 35 would be right here. That's where Brennan's dot is. So all of these points are just plotted here, and that's your scatter plot. Okay, here's another example. It says the table shows the number of cookies in a jar from the time since they were baked. Okay, so 1 day since baking, there were 24 cookies. 2 days since baking, there were 16. 3 days since baking, there were 10, which makes sense. It's going down because the more days go by, the more cookies you're going to be eating. So there's going to be less cookies in the cookie jar. Okay, so again, you're going to notice that all of these points are plotted. 1, 24 is right here. And so on. So that's all there is to a scatter plot. Okay. Now, the next page is going to talk about the correlation between, which is a relationship between points. Okay, so a correlation describes a relationship between two data sets. A graph may show the correlation between data, and the correlation can help you analyze trends and make predictions. And there are 3 types. Okay, so one type is if the dots seem to be headed in an upward trend, we call that a positive correlation. If the dots seem to be headed down to the right, that's a negative correlation. And if they're just kind of scattered all over the place and I can't tell if it's increasing or decreasing, we say that has no correlation. Okay, so the next part says describe the correlation illustrated by the scatter plot. So the first one is about beach visitors, okay, average daily temperature and visitors. Okay, it actually doesn't even really matter what this is about. We're just trying to say, is it positive, negative, or no correlation? Okay, so this one, as you can kind of tell, as temperature increases, number of visitors increase, and that makes sense because the warmer it is, the more people want to go to the beach. So you can see this is kind of an upward trend, so we're just going to say that that is positive. Okay, the next one actually is the temperature of a pie after baking. Okay, so you can kind of see here that as time goes on, the temperature of the pie is dropping, right? At 0 time after it's done baking, it's pretty hot, and then it starts to cool off the longer it's been out. So as you can see, this is starting to kind of slope down to the right. So this we would say has a negative correlation. Okay, this next one here has to do with how old you are and how many pets you own. And as you can see, they're kind of scattered all over the place. So this one, we're going to say there is none. There's no correlation. And that should make sense because just because you're a certain age doesn't mean you have more or less pets. Okay, and then here we have a snowboarding competition and the number of participants. As you can see, over the years, the number of participants seems to be increasing, so that would be a positive correlation. Okay, so now we're going to be able to tell what kind of correlation there is just by some the variables that we have, not even looking at a graph. Okay, so it says identify the correlation you would expect to see between the pair of data sets and explain. So the first one is the average temperature in a city and the number of speeding tickets given in the city. So we have to ask ourselves, does the number of speeding tickets usually depend on what the temperature is? And the answer is no. I don't think you're more likely to give out more speeding tickets when it's cold or when it's warm. Okay, because that doesn't really affect people's driving unless there's like snow or other things on the road. So temperature is not going to affect the number of speeding tickets. So I'm going to write none. Okay, and it does say to explain, and so we'll do that by saying that temperature doesn't affect speeding. Okay. So the next one is a runner's time and distance to the finish line. So a runner's time is like what they're, how long they've been running, and the distance to the finish line. So we have to think about this, right? As time increases, what happens to the person's distance to the finish line? Well, as time increases, they would be getting closer to the finish line, which means their distance to the finish line would be decreasing. Okay, so as I'm going to leave room for the answer here, but as time increases, distance is going to decrease, right? The distance to the finish line is going to decrease. So when this happens, if one is increasing, the other is decreasing, that is going to be a negative correlation. Okay. The next one is the number of people in an audience and ticket sales. So the number of people, as that increases, what would happen to your ticket sales? Well, the more people you have, the more ticket sales you're going to have, right? So if they're both going up like this, so as the number in the audience increases, your ticket sales are also going to increase, right? So when both of them are positive like this, okay, they both go up, that's going to be a positive correlation. Okay. The next one is the temperature in Houston and the number of cars sold in Boston. So does the temperature in Houston affect the number of cars that get sold in Boston? And the answer is no. So this one, there is no correlation. I'm just going to say none. And that's because the temperature in Houston doesn't affect car sales in Boston. Okay. The next one says the number of members in a family and the size of the family's grocery bill. So let's think about it. As family members increase, what happens to your grocery bill? It's going to increase. So since one increases makes the other one increase, that is a positive correlation. So as number in family increases, the grocery bill is going to increase. Okay. The next one says the number of times you sharpen your pencil and the length of your pencil. So number of times you sharpen your pencil, does that affect the length of your pencil? And the answer is yes. So I'm going to leave some room for the answer again. So as the number of sharpenings increase, what happens to the length of your pencil? Well, the length is going to decrease, right? It's going to get shorter. So since as one goes up, the other one goes down, that is a negative correlation. Okay, please let me know if you have any questions on this assignment. We're going to spend another day on this week as well.